Hi everyone, we are moving on to polar, and so quick review. So first, just graphing polar coordinates. Right, so we're going to graph these four polar coordinates, and hopefully you remember the first number in polar is our radius, or our distance that we're traveling. Our second number is theta, or our angle, which is stated here. Right, so our point A has a radius of 4 and an angle of 2 pi over 3. So I'm going to find 2 pi over 3. So this angle right here, I'm going to go out 4 units. 1, 2, 3, 4. And this is my point A. Right, so similarly for B, 7 pi over 6 is my angle, and I go out 3 units. So 1, 2, 3. This is my B. Right, for C, I have a negative radius, so I'm going to find 5 pi over 4, which is right here. And instead of going forwards, I'm going to go backwards 2 units because I have a negative radius. So 1, 2, and that's my C value, or my C point. Right, and then D, I have a negative angle, so instead of going counterclockwise to pi over 6, I'm going to go clockwise to 11 pi over 6, which is the equivalent angle of negative pi over 6. And I'm going to go out 2. So 1, 2, and this is my D point. Right, so those are my 4 points. Right, so a little bit of review. So we know that cosine of theta. So first, let's draw us a triangle. This is a right triangle with some theta. Okay, obviously this is x because that's lateral movement, and up and down is going to be y. It's my vertical movement. And this line right here is my r value. This is going to be the radius of whatever I'm talking about, say, for instance, a circle. Well, for cosine, I know that's adjacent over hypotenuse, so cosine would be x over r. Sine would be y over r. And tangent is sine over cosine, or alternatively, it's slope, and so you always know it's y over x. Okay, and from the Pythagorean theorem, we know that x squared plus y squared equals r squared. Okay, so if I wanted to take some of these and simplify them, here I could simplify and solve for x by multiplying both sides by r. So I get that x equals r cosine of theta. Same thing here, I multiply both sides by r, so I get the y is r sine of theta. Right, and then here, if I just solve for r by rooting both sides, I get plus or minus square root of x squared plus y squared, which should look familiar. This is also distance. And again, this is like the equation of a circle in standard form with a center at 0. Right, so kind of all this stuff relates. So first thing they ask us to do is convert 2 and 5 pi over 6 to rectangular coordinates. Okay, so all I have to do is, well, first let's talk about what each number represents. Okay, this 2 is my radius, this 5 pi over 6 is my theta. So I'm just going to take these, plug them in, and solve for x and y, because that's what comprises rectangular coordinates. So x equals r cosine of theta. My r is 2. My theta is 5 pi over 6. Right? Cosine of 5 pi over 6 is negative root 3 over 2. So I get negative square root of 3. Y is r sine of theta. So in this case, again, 2 is my r. I have sine of 5 pi over 6 this time, which is 2 times 1/2, which is 1. So my rectangular coordinate would be negative square root of 3 and 1. Okay. This time let's convert rectangular to polar. So this is x and y. So I think it might help a little bit if I draw. So if we plot our point, it's about here. Right, so let's say this is 3, negative 3. So I plotted this point here, it's 3, negative 3. That means I have a triangle with a lateral distance of 3 and a height of negative 3. Okay, so I went across 3, I went down 3. Okay, well, the things I need to figure out are my angle right here, which you could probably guess because this is isosceles. And it's a 90-degree angle here, so you kind of know what this is. And I also need to figure out what the hypotenuse, the length of the hypotenuse is. Okay, well, the way that I would do that is by starting with tangent of theta. Okay, so tangent is real nice because it involves both x and y. So tangent of theta is going to be my opposite over adjacent, or negative 3 over 3, which is negative 1. So if I do arctangent of both sides, I end up getting negative pi over 4. And you can kind of see that because you know that this is going to be a 45, 45, 90. And because we went clockwise for our angle, we're in the fourth quadrant, it's going to be negative pi over 4. Okay, and then just using the Pythagorean theorem, we can find the length of our hypotenuse, which is going to be the square root of 18, or if we reduce that, 3 root 2. And so our coordinate is going to be 3 root 2. I have no idea what just happened. 3 root 2 and negative pi over 4 is our angle. All right. Next, we're going to convert to polar form. So I'm given that y equals 4. Okay, y is the same thing as r sine of theta. Right, so let's solve for r. So r is 4 over sine of theta. Same thing as for cosecant of theta. All right, so now I have a polar equation in terms of r and theta, which is what I wanted. All right, so similar thing here. Well, I know that x squared plus y squared equals r squared. Okay, we talked about that on the previous page. So r squared equals 25, meaning that r equals 5. So essentially a circle with radius 5 can be represented in polar by just saying radius of 5. Okay, so if your radius is 5, you don't specify an angle, then you just do all the angles with a radius of 5, which is a circle. All right, let's do some graph sketching and converting to rectangular form. So r sine of theta is the same thing as y. So I'm just going to make that substitution. And y equals 3 is just a horizontal line at 3. Okay. Now, just cosine of theta by itself, can't make a direct substitution there. I know that x equals r cosine of theta. So cosine of theta is going to equal x over r. Okay, so I'm going to multiply both sides by r. Okay, and r squared is the same thing as x squared plus y squared. All right, so you'll notice that I focused on getting rid of this cosine of theta first. Theta is going to be what I want to sub out because it can be kind of the trickiest thing. Okay, now if you subtract 2x from both sides and complete the square, you end up getting that this is a circle of radius 1. And it looks something like that. Guess what that is. Okay, last one. What I'm going to do is take the tangent of both sides. The reason being because tangent of theta is something I can work with. Theta by itself isn't all that useful to me in terms of substitution. So I know the tangent of theta is y over x, and tangent of 2 pi over 3 is negative root 3. I multiply both sides by x, so y is negative square root of 3x, so I have a slope of negative root 3, so it's going to go down like that, and up like that, and that's supposed to be a straight line. Ooh. That's close, whatever. Okay. So in terms of finding the derivative in polar form, it's the exact same thing as parametric, except we have d theta instead of dt. Right, so if you want to find dy dx, and you have polar equations, you find dy d theta and divide by dx d theta. There's some rule here that's really complicated. We're not going to use it. Okay, this is what you have to remember. It's the same thing as parametric. So let's practice that. Okay, so x is r cosine of theta. Okay, so my radius is defined as 3 plus 2 sine. Okay, and this cosine is just that cosine. Y is defined as r sine of theta. So again, my radius is defined as 3 plus 2 sine of theta times sine of theta. All right, so kind of complicated, but it's all good. So now I need to figure out what dy d theta is divided by dx d theta, and that will give me my dy dx. So I need to take the derivative of y first. So we are going to have to use product rule here because I'm multiplying two functions. So the derivative of 3 plus 2 sine of theta is just cosine. Right, this time 3 plus 2 sine of theta chills, and the derivative of sine is going to be cosine. Okay, now we take the derivative of x. So again, the derivative of 3 plus 2 sine of theta is going to be 2 cosine of theta. I should have a 2 here, shouldn't I? 2 cosine of theta times cosine of theta. I'm going to put a minus sign here actually, and the derivative of cosine of theta is negative sine of theta, which is why there's a minus sign right there. Okay, and I wanted to evaluate at pi over 6. So dy dx evaluated at theta equals pi over 6. Again, this is a problem for your calculator unless you want to do, I mean, you could do this by hand pretty easily, but you get negative 5 root 3. Right, that is it for these notes. I'll see y'all later.